So what I'm going to go through is both empirical and theoretical issues in the theory of demand, having done supply last week and pointed out why the supply curve, the idea of rising marginal cost is simply empirically false. And when you think about it, when the factory is well designed, logically false as well. What engineer would design a factory to have the characteristics that economic theory thinks all factories have? So that's the whole idea of diminishing marginal productivity. Is a nice sounding concept that just is not going to work in a well-managed factory. It's not going to happen in a well-managed factory. And so you're going to find there that, why do they push it so much? It's because the whole idea of diminishing marginal productivity gives them rising marginal cost, which is an essential part of their theory of supply and demand. That's where it all comes from. And what you get, of course, the basic rule is that marginal productivity is constant or rising as the factory heads towards full capacity. And therefore marginal cost is declining. The fixed and marginal costs are on much the same scale, whereas in the basic theory they're always known as massively different. So firms that set marginal cost equal to price would go bankrupt. Rather than being profit maximising, it's life-threatening to be charging at marginal price. And when you think about this in the context of things like cars, chairs, anything we actually use on a regular basis, computers, etc., the marginal cost is relatively trivial. It's the development costs that are the large part of getting anything of that going. So here's a bit of a refresher now, largely for your benefit, but I'm glad you've kept up with it. And that is that what you have is, in the vision the neoclassical economists have about the market, is that it's a system for reaching a balance between the desires of consumers on the one hand and producers on the other. So consumers would like low prices, producers would like high prices. The market gets you a combination between the two. And the way they draw it is they model quantity on the horizontal axis and price on the vertical. But in fact what they say both consumers and producers are reacting to is the price, which is therefore mathematically the price should be the horizontal and the quantity should be the vertical. And that does lead to a range of issues, but I'm going to skip over those. And what you get is they talk about inverse demand. So you'll see that in the literature, the inverse demand curve or inverse supply curve. That's why they're using the term inverse. So don't worry too much about it. It does make a difference, but I'm not going to worry about it too much here. And what they show for consumers is this demand curve. So the higher the price is, the lower the demand. So you get a falling demand curve. And for producers, the higher the price, the higher the supply. So a rising supply curve. Both of which look superficially attractive. This is an important thing because if you heard of the concept of what's called a meme, you heard what a gene is, like a gene reproduces biological systems. A meme is an idea that reproduces itself over time and shapes how you think. And that meme of the intersecting supply and demand curves is extremely strong in economics, and it's the thing that's permeated how we think about a market economy, even though there's people who don't do economics. So here's I'm tearing apart a textbook by Greg Mankiw. I've actually found one thing Greg Mankiw wrote was quite useful. That does not include his textbook. I'm using other work of his. But here's the idea of equilibrium of supply and demand. That's the basic idea. Equilibrium, supply and demand. That you have a downward sloping demand curve, upward sloping supply curve. You get equilibrium quantity down here, equilibrium price up here. And it's a balance between the advantages for the consumer and the advantages for the producer. That's the basic vision. And what they'll show, and this is again, textbooks have been simplified radically over the last 40 or 50 years. My school textbooks included stuff which is regarded as advanced second year material today. I hate to tell you that, but it's true. But here's the sort of stuff you'll see in a book like Mankiw. What he has is the price of an ice cream cone, hang on, over here, between $1 and $3, and the number of demanded between 12 and 0. Notice how large the market is. 12 ice cream cones an hour. They're childish numbers all the way through the numbers that are the kids' examples. It's engineers would rightly laugh at the stuff we have published in textbooks. And then supply is also shown as a schedule, so rising supply, falling demand, and then bang, you have the two being intersected together. Now they're individuals, individual demand, individual supply. Now they show for the market, they show that you can horizontally add consumers' demands to get a market demand curve, Nicholas and Catherine in this case. Ben and Jerry. Okay, there is an ice cream company called Ben and Jerry, so fair enough. But Ben and Jerry's supply are added horizontally. You get the market demand curve, and it's all nice and simple. Okay, that's the way it's portrayed in the textbooks. Now, if you look what they call the advanced section, which is now occurs at the end of Mankiw's book and often doesn't occur in any. In a lot of first-year textbooks don't even cover this derivation. They've shunted it on to second year, which is why I say there's been this reduction in complexity, not complexity, but reduction in the detail that they give you. So by the time you've been through a year of this stuff, then you finally get to how they derive it. And if the derivation brings up problems that aren't obvious in the little summary at the beginning. So here you have this idea of diminishing marginal productivity. So this is showing the level of production, number of workers hired, 5 workers producing 150 cookies an hour. I mean, again, that's that is not the factory from which you buy the stuff in the local supermarket, let me tell you. You have falling marginal product, and therefore, notice this here, diminishing marginal product all the way through. This is an essential concept in their thinking. It's empirically false, essential part of the model. So when you have diminishing marginal productivity, you get rising marginal cost. Therefore, you're paying exactly the same wage for the workers you're hiring. Notice the 10, 20, 30, 40, 50 dollars an hour. There's no change in the number, the pay rate you're paying per worker, which is one reason you might think you get a rising cost of supply. Well, they rule that out and say it's not because you're paying more for the workers, it's because the productivity of the workers is declining as you produce more output because you're getting more and more workers crammed around these machines. Okay? So again, diminishing marginal productivity is an essential part of their thinking. And they break this down into various types of costs. So there's fixed costs, which is basically your factory, and notice how expensive this factory is. It costs $3. That's a really radically expensive factory, $3. And then the variable costs start off at only 30 cents and rise to 12. Okay, so average fixed costs fall from $3 per unit when you're producing one glass of ice. They expect me to take them seriously, honestly. One glass per hour, variable cost of 30 cents per glass, and then you get up to the stage where finally it's 10 glasses an hour. I mean, wow, that's a factory working gangbusters, 10 glasses of lemonade an hour. So you have the idea again here of rising marginal cost because of falling marginal product. You're paying the same wage per hour, it's just the workers are getting less productive because, gee whiz, once you're producing 10 glasses of lemonade an hour, my God, you're working fast and you're bumping into each other and the machines are burning up within, oh, God, give me a break. Anyway, so it's all childish stuff, totally childish stuff. So they draw this is the drawing that comes out of it again. This is the one that I showed you last week. And again, this idea of trivial fixed costs, high marginal costs, okay, high variable costs giving you high marginal costs. And and therefore this rising marginal cost becomes an essential part of it. Marginal costs being far above fixed costs. You can see at this point, after 4 units, the marginal costs are exceeding the fixed costs. Tell that to Elon Musk. And I just love this bit. I only spotted this just recently. This is the explanation. He's actually using the idea that everybody's crowded around machines and bumping into each other, and that's why productivity has fallen. When a quantity is produced is already high, like 10 glasses an hour, the marginal product of an extra worker is low, and therefore the cost is large. Kids stuff. Now, what they notice that I've got perfect competition in inverted commas, and I'll be showing you why in the next couple of. I'll take more than this lecture to get through it. Perfect competition reaches the result that the marginal cost curve above either average fixed cost or average variable cost or average total cost is the supply curve. They'll say, in general, they say a firm will only sell if its marginal revenue is above its average variable cost. But this is the point where they take the basic supply curve, from this point up where marginal cost exceeds average total costs. As I showed you last week, empirically there is no such point. Okay, it's again their little model. But that's where their supply curve comes from. Crowded conditions, 10 glasses an hour. Anyway, so here they'll say a firm in a competitive market, like most other firms, tries to maximise profit. And profit is total revenue minus total cost. So I want to go through the logic of all this here, and they say the firms maximise profit by finding where they're constant or falling marginal revenue, and that's the part I'm going to be largely exploring today, equals their rising marginal cost. And notice, whenever I think this is nonsense, I'm going to put a strikeout through it because that's what they believe. In fact, empirically it doesn't work. But it starts from assuming there's a downward sloping market demand curve. Okay? That's an assumption. I want to show just how well-grounded is that assumption in their own theory. I'm quite okay with the argument that for ordinary commodities, up to including cans of Coke and stuff like that, the higher the price, yes, demand is likely to fall. What I'll be showing you is they have no explanation for it in their own theory. They believe they do, but they actually don't have that explanation. That's why Samuelson's stuff was so strange. So what they do is they have this inverted Marshallian diagram, so the quantity on the horizontal price and the vertical. And this is just, I'm now using one of my own maths programs just to get some reasonable numbers here. So I'm talking 20,000, 20,000 cars a month, for example, that sort of level, something of that nature, with and a price between 0 and 1,000. That's a straight linear demand curve. Now, if you have that, then to increase your sales, you drop price. So you've got a larger quantity but a lower price per unit. So there's average, your revenue will fall for a while. If you charge a price when nobody buys anything, then your revenue is 0. If you drop the price but you get one customer, your revenue is much larger than 0. So you get this rising total revenue initially, but rising at a declining rate. So here, just to give an example of that, if you're selling, say, I've got 2,000 units here, and the price on this function I've got is therefore $900. 1.8 million comes in. And then if you go out to a price of 600, you've dropped your price, but you're selling 4 times as many units. Your revenue is 4.8 million, so you've got a $3 million increase in your revenue. And the way they would interpret that is to say at that stage demand is elastic. So a fall in price of 1 gives you more than 1 increase in revenue. That's what they define high elasticity. When you get down here, you start getting low elasticity. Okay? But there's obviously a maximum to this whole thing. If you draw a curve like that, there's some point where there's maximum total revenue. So if I graph that, what I've now got, here's the curve of total revenue graphed on the right-hand side. And there's its peak, quite obviously. And this is the blue line is showing how revenue is changing, total revenue is changing for each new item being added. So there's the price you're getting, which is an average price. Because you've got to drop the average price to get each additional unit, and the marginal declines. And what the marginal is basically the slope of that curve. It's just based straight differentiation. So clearly the slope of that curve is 0 up here, 0 down there. Okay? So maximum slope, this one's got declining slope all the way. So having done that, you've got, now I bring in the idea of rising marginal cost. So if I now show total costs here with another function, and that's the shape they want to have for total costs, rising, the rising marginal cost idea. So what you're trying to do is you're not trying to find maximum revenue, you're trying to find the maximum gap between these two curves. Okay? That's the idea of maximising profits. So you get that gap, you've got to find where that gap is. And what they're saying, well, you can use calculus to do that because the gap will be, given the characteristics they assume for these two curves, so this one is diminishing all the way through, and this one is rising all the way through, where the slopes are the same, the gap will be maximum. And that's the idea of equating marginal revenue and marginal cost. So if I put that together on the next chart, this gets to be a very messy chart. But what I've got here is there's your total revenue, there's your total cost, and so there's total revenue, there's total cost. Hang on, which one's? Yeah, that's the total cost one, pardon me. And you're trying to find the maximum gap between the two, and it happens to be there. Okay. When you take a look at it, that's also where marginal cost, which is the slope of the cost curve, is the same with marginal revenue, which is the slope of the revenue curve. And they normally leave that out. And the reason that I slotted the flaw that I'll be showing you, not this week but next week, is I graphed all this stuff in totals. And I suddenly saw an inconsistency between their model for a monopoly and their model for a perfectly competitive firm. when you look at the aggregate level. But I'll talk about that next week. I'm not doing that today. So there's your maximum profit. It's where marginal cost, which is the slope of the total revenue, marginal revenue, which is the slope of the total revenue curve, the same as marginal cost, which is the slope of the total cost curve. There's your maximum gap. So you find this little point there, and that's the diagram that they give all the kids. And they really are teaching adults as kids when they teach this stuff. Marginal revenue equal to marginal cost, there's your profit maximising point. Now, the perfectly competitive market has the distinction that, yes, the market demand curve still slopes downwards, so they still have exactly the same idea shown for the overall market, that to increase the quantity being sold, you've got to drop the price. But they say the individual firm faces a horizontal demand curve. Okay? Have you heard that concept before? Okay, good. If you're looking, does it sound sensible? Yeah, wait and see, but it's not. Okay, I'll show you why next week. So here's Homankyu again. The competitive market has two characteristics, and I want you to focus just on what they say are the defining characteristics. Many buyers and many sellers, so lots and lots of firms and lots of buyers, and the goods are largely the same. And then they say, as a result of these conditions, now notice there's nothing in those conditions about firms reacting to what each other firm is doing. Okay? It's just saying because there are so many of them. There's nothing about whether one interacts with another. And this used to be called the assumption of atomism. The firms are so small, they're like atoms. Atoms don't think about what other atoms are doing, they just do their thing. So these firms ignore each other, and they set their price given what they see as the demand. And because of the characteristics of many, many sellers and many, many buyers, they face a horizontal demand curve. That's the argument that's normally given. That's been, over time, that's been dumbed down to the explanation. They don't talk about atomism in the textbooks anymore. They used to when I did my undergrad in my high school in economics. But a large part of what they're saying today involves interaction between firms. There's another theory of competition called Corno, game theory. And Corno says firms will strategically react. What will happen if I make a change? What will another firm do? And what's the prisoner's dilemma outcome of those? That's a different explanation. Okay? And I want to show that they're in conflict with each other, but I'll do that next week. So what you get, each prior, because there's so many buyers, just because there's one condition, says identical goods, and many buyers, many sellers, therefore, each part takes the price as given. That's their argument. So they market for milk, and they come along and give an example here of essential milk, essentially identical milk being produced by different farms. They'll then say the price in the Smith farm doesn't depend on the output they produce. If they produce, 1,000 litres a day, they sell it for $1 a litre. If they produce 10,000, they could sell it for $1 a litre. No impact on the price they're getting. So they draw a schedule like this, and this has total revenue, price just remaining constant all the way through, whatever 6Q stands for. What is that, 6 cows a day or 6 litres of milk a day? God knows. And that's the constant price, constant revenue per unit, average revenue the same. So marginal revenue is exactly the same as average revenue. In other words, marginal revenue is price. So before, when I showed you on the diagram for the market, they're different curves. Here they're the same for the individual firm. And in general, what they'll say about firms in general is all firms maximise, whether they're monopolies or oligopoly or competitive, whatever they are, they maximise by equating marginal revenue and marginal cost. Okay, so they order that thing. So given this particular type of market, the marginal cost curve becomes the firm's supply curve. So what you draw is a horizontal, I've got a price of 500 now, and the more realistic numbers I was using in my previous graph. So the price is 500 no matter how many units this firm produces. So what you get is constant marginal revenue, constant price. Therefore, total revenue just rises as a straight line. Okay, you've still got the idea of rising marginal cost turning up here. So your gap is now going to be further out, because if I had a downward sloping line, I'd have a point of maximum back here somewhere. Instead, the point of maximum is out where the slope of the marginal cost curve is the same as the slope of the total revenue curve. So these firms supposedly profit maximise by setting marginal cost equal to price. Okay? And that's an essential part of neoclassical theory, including their macroeconomic theory, because these days they base their macro on their micro. So what they then say, let's add up all these marginal cost curves. Here's Ben and Jerry again, horizontal addition. We get a market supply curve coming out of that. Now, that only applies to competitive markets. If you look at what they call oligopoly or imperfect competition, where there's some product differentiation and so on, then you can't do it, because here's Mancu's animations for this, not mine. So they have cost and revenue, rising average total cost, rising average variable cost. Then show price equal to marginal revenue. This is a competitive firm. And they're drawing a marginal cost curve. Notice how steep it is. So what they say is, well, there's going to be one, given that particular price, that'll be the quantity that maximises profit there. And then if you have a lower price, then that's the quantity that maximises it. Again, there's the next one that maximises it. All of them lie on the marginal cost curve. So therefore, the marginal cost curve is the supply curve for an individual firm. And then add those up to get the market supply curve. And what I want to do here is illustrate why you can't do this with any other market structure. Because if you say there's rising marginal cost, that's again a Mancu line, and now I've got falling price, therefore marginal revenue falling more steeply again, this particular firm would maximise profits by choosing that point. That's profit. That's the point. That's where they decide the output to produce, and that's the price they can sell it at. Okay. So what you get is there's the combination they'll produce. Okay. So there's your equilibrium price and equilibrium quantity when there's a downward sloping price and therefore downward sloping marginal revenue. Now, if you consider a different shape of the demand curve, so it's more elastic, okay, then when you work out your points again, you get a second point here. So there's a quantity, there's your price. Now let's join those 2 points up, because one's a point of supply and the other's a point of supply. What do I get? I get a downward sloping supply curve. Okay. So they don't want that. Okay. There's no way you can actually draw a supply curve which has the characteristics they wanted to have unless you have perfect competition. And that's why they obsess about perfect competition, because you can't derive a supply curve independently of the demand curve unless you have perfect competition. That's why it's such an essential concept to them. And if that's the case, if you can't derive a supply curve without knowing what the demand curve is, then you can't do supply and demand analysis. That's why it's so essential to them. And you'll find all the time, even though they tend to just wave their hands and go on with it, most of them don't even think about these issues. But when you try to nail them down, why is perfect competition so important to you? They'll say, oh, that's what describes, that's our simplifying assumption for the real world. Garbage. It doesn't suit the real world at all, as I've shown it can't happen for the vast majority of firms, because they have constant or falling marginal costs. They can't get there. It's necessary for supply and demand analysis. That's why they're obsessed with it. So, the demand curve. Let's take a look at it. And this is when I'm going to start getting slightly heavy today. Not as heavy as I could be, but again, to give you an introduction to it. They derive the ideas. This is when they go to the advanced bit. So rather than just drawing a schedule and saying that's the demand curve, they now say, well, let's try to derive a demand curve from what we believe are the characteristics of a rational human being. And they say, well, the rational human being obeys what are called the axioms of revealed preference. Have you heard of that before? Did you cop that last year when you were doing, yeah?
A little, yeah. I didn't go heavily on it.
Pardon?
Yeah, a little.
Not a lot, okay. What they say is that if you imagine what you are as a consumer, you have a complete set of preferences for all the various combinations that I can show you that you might decide to buy with your money. So you also can decide you're logical. So if I give you one basket and you prefer it to another basket, that's always going to be the case, because you prefer the first one to the second, no matter what the prices might be. And the more I give you, the more you like. So I can never satiate you. Okay. And there's got what's called convexity, which means, again, like they've got the idea of diminishing marginal productivity. what they have, really the model of production is a remapping of the model of consumption. Because with consumers, they say one banana gives you X amount of, some amount of utility, two gives you more, but the second banana gives you less utility than the first banana. Okay? Well, that's what they're applying, and they've basically flipped it over and made it a theory of production as well. So they say irrational utility maximizes, and irrational, you obey these rules, which Paul Samuelson, you'll get used to that name, first developed. And completeness says, given any two bundles, you can decide whether you prefer bundle A to bundle B to bundle A, or you couldn't care which one you get. So that's the idea of completeness. Transitivity says if you prefer bundle A to bundle B and bundle B to bundle C, then you prefer bundle A to bundle C. And think of these in terms of shopping trolleys. Okay? That's an important little visualisation I want you to have in your head. Two shopping trolleys, I can say which one do you prefer, and you know which one you prefer. And that's independent of the prices of the products in the shopping trolleys, just what you would like to eat. Yeah. Non-satiation, so I put one more item. If you prefer A to B and B to C, and I put one more item in A and not in B, and that flips it around, then I'm just showing you want more of what I'm adding to the basket. And you get more utility out of each product you consume, but that extra amount of utility falls over time. So what you can do with that is therefore represent a person's preferences for commodities by drawing what they call a utility surface. And this has what are called indifference curves. And you think about it, you've all watched the weather report. Okay? And you're used to seeing all the isoquants and moving stuff on maps, and that's really impressive mathematical analysis. That's brilliant stuff, and it's real. What it's telling you, isobars are the points of equal pressure. Okay, so it's describing pressure cells which are part of the whole circulation of the atmosphere. That's real, okay, and it's meaningful. And what you're doing is using exactly the same sort of information they're using here, because rather than showing you the actual physical pressure, they're showing you lines of equal pressure. Well, these are supposed to be lines of equal satisfaction. So here we have, with the difference curves, all point on the higher curve, like I've got curve Z, I've got the W, X, Y, Z here, and here with B and A, they're two vastly different amounts of bananas and biscuits, but the idea is they both give you the same utility. It's like having a curve, a high pressure cell over Scotland that also goes through London, so Edinburgh and London have got the same pressure. Same sort of idea, same amount of utility out of consuming those amounts. Then, if you have any amount Z, you prefer to anything on this B curve. So anything that sits on the Z curve is preferred to anything on the Y curve. And then, if I take this point P, then anything above and out, because it has more of the two items, you must prefer anything in the triangle to the point P. So that's the basic notion. Now, Samuelson dreamt this up. Get his name? Paul Samuelson. You know, he has a relative who's alive and kicking these days called Larry Summers, an in-law. Larry Summers is Paul Samuelson's son-in-law. Paul's long dead. Okay. So the people said, look, this is interesting, but we can't see indifference curves. It's unobservable. And Samuelson was a big one for trying to make economic what he called scientific. So he said, well, that's a good objection. But I want to show you can actually work out what somebody's indifference curves are by what he called the axioms of revealed preference. That's where he jumped out a particular idea. And what he said was, you can't actually see people's indifference curves like you can measure pressure. Okay, we have literal weather stations measuring the weather, temperature, pressure, etc., all over the world. That's not done for consumers. It can't be done. But he's saying we can still infer them. So what you do, for example, is we know that more is preferred to less. So if you give a person a bananas and biscuits, that particular shopping trolley, then anything which has got more of either, they must necessarily prefer it because that's rational, that's satiation. Okay? So anything above there must be on a higher indifference curve. Then if I give you a choice between A and B and C, and you prefer C to B, and A to B, then C must be on a higher indifference curve than A, and A must be on a higher indifference curve than B. Okay, so once you start mapping like this, ask people questions about what do you prefer, you can derive their indifference curves by observation of what they actually choose. And you can go through this lovely long process and say, okay, well this must be, this is a different, what now shows a budget line. And so you do what's feasible with the budget as well. So by putting a combination of prices together, relative prices and incomes, You can go through a laborious process, and I could work out what your indifference curves are. Okay? So once you've done it, you get this little story. These are a set of indifference curves. And then I can give you various relative prices. So these 3 lines here, this one has a higher price for bananas, so you can buy less bananas, a lower price and lower price still. This one doesn't change because I'm not changing your income. So I'm assuming, and this is very important, I'm assuming that varying the price of bananas does not change your income. That sound like a reasonable assumption? It is a reasonable assumption in this room. Okay, does anybody here produce bananas? Okay, so it's reasonable when you can abstract from that overall situation. What you then, I don't know, this is actually, it must be a timing thing shot of this particular set of slides. I better go and check that. I can't stop it. Damn! I didn't know they had automatic on this particular slide. So, hang on, if I can go backwards.
Steve,
yeah?
Are we talking about constant income? Are we talking about nominal income or real income?
We're talking real because they're talking in terms of relative prices. So they don't actually have dollars and stuff in their thinking. Yeah?
But how can I compare the utility of bananas to the utility of biscuits? What kind of measurement is this?
Good. That's what I'm saying. And I'm not going to try to drive you insane by insisting you're wrong in saying that, which a neoclassical lecturer would say.
You can't measure it. It's just like I say this is the utility for bananas. For me it's like 1.
Yeah, that's it. You don't want any more than 1. You're sensible, okay? This is an economic theory, so please don't try to judge it on the basis of whether it's sensible or not, because it's not. Yeah.
So if you're dealing with an item that made up 30% of someone's expenditure, you still wouldn't do a real income adjustment?
No, you wouldn't. Okay, because you assume you can change the price with it, but that becomes a big issue later on in today's lecture, but it does become an issue when you try to get a large model. I'm sorry about this continuing to. It must be a timing thing I set up on these slides some time ago, and that's why those things are moving forward. I want to just, if I can freeze it, I might freeze that just by going back to here for a moment to show what I'm trying to indicate. So what?
Does your indifference curve change with time?
No. Oh, God, no. Can't have that. You don't even ask it. It's immaculate conception.
Yeah.
You're immaculately conceived. You're born with preferences for Rolls Royces. Okay? And Lamborghinis and Mars bars, and of course you're born for preferences for trips to Mars as well. There's no question about how these are actually generated. Just to take them as immaculately conceived and independent of any advertising and so on and so forth. That's just not considered in the theory. But what you can do once you do this is you say, here's your, if there's a very high price for bananas, and you're going to have a low quantity you buy of them, so there's the price, the relative price of bananas shown down here, there's the quantity, so there's 1 point on the demand curve. Then we have a cheaper price, you buy more of them, there's your second price and quantity combination, and out of that you derive an individual demand curve. So I'll go back and that's the way they derive a demand curve. But they do have the problem. This is a demand curve that slopes down, which is what they want. But part of their point is say, well, if you have and this is partly your point earlier, if there's an item which is a really big part of your expenditure, even if you don't like it, if its price rises, you may consume more of it because you can't afford to buy anything else. And this is their explanation for the potato famine, the Irish potato famine. They call them Giffen goods. So let's just go down one page and I'll cover that logic. This must be an automatic setting on the slides I've imported into this presentation. I don't like slides jumping ahead without me being able to control them, but I'll fix it up later. So what they're saying is you can consume more of everything. If the price of one commodity drops, so bananas get cheaper, you therefore can spend more on everything, including not just bananas but other items. And maybe if you don't like bananas, because the price has dropped, you can afford to buy more of other stuff. You might buy less bananas as the price falls. And that's what they call the substitution effect and the income effect going in opposite directions. With the substitution effect, you will always buy more of something if it gets cheaper. With the income effect, if you don't actually like that thing, you'll use your effectively higher real income because of the lower price of one item to buy more of other stuff and less of that. So another guy who's very important in the development of economic theory comes in here, a guy called John Hicks. You heard of his name before? Some of you have. John Hicks was a contemporary of Keynes, so he predates Samuelson. In some ways, he was the Samuelson for that time. And he realised this problem with indifference curves, which predate Samuelson Samuelson brought along the axioms of revealed preference, but the idea of indifference curves was around for a while. And what he said is, well, if you drop the price of something and then you compensate, this is annoying. God almighty. Hang on. I better stop and talk to the slides. You can see where I was going with this one. It gets boring. Okay. But if you, let's go back up one page. Okay. If you, because I was working on these slides, I didn't notice the timing effect. Now I'm finding out the hard way in the class. I'll have to fix that later. But if you have a income boosted because the price of one commodity has fallen, then your general capacity to buy has risen. So the drop in price has caused a change in your effective income. And that therefore can distort their analysis, because what they want to show is that things get cheaper, you buy more of them, no matter what you're talking about. So their argument, Hicks's solution was to say, well, let's take account of the drop in price. That then will let you get to a higher level of utility overall. Then what we do is we adjust your utility, say, back to the previous level, and therefore we necessarily show that you will consume more of that good because you're on the same indifference curve. That's the logic. So, unfortunately, I'm sorry that this goes with this badly timed animation. Hang on. So you have an initial budget line. You therefore choose a combination on that budget line. Let's see, now it's stopped. Great, okay. That's where your current point. You then have a cheaper price. That's like this. You have a new combination. There's your new consumption point. You then move that point of the tangency back, effectively reducing your income back to the same effective level as beforehand, so you're getting the same level of satisfaction. And then when you look at the curves that are the demand curve you can draw out of that, it necessarily slopes downwards. And that's what they want, which is incredibly boring. Okay. But that's the logic they're going through, this particular process of working out a set of indifference curves which necessarily slope downwards. So, well, let's just now take a step back and do the empirical logic here. How did that actually work out? Because there was a lecturer, I must meet him one of these days, called Sippel in Germany, and he decided to test this, and my feeling is that he thought he was trying to enliven a class, so he had a group of 12 students in a small seminar group, and he thought he'd actually derive their indifference curves for them. And he did it very, very carefully, and it didn't work. Now, before he did this, a range of people did different attempts to test the theory, including, as your point about do the preferences change with time, took a survey of household expenditure over time. Well, preferences do change with time, so that made it rather unreliable. Others even studied people in a psychiatric hospital. They got a deal that they could use the internal shop inside a psychiatric ward and change the prices for stuff that they got, the toy money the inmates had, and they're trying to test whether people in the psychiatric are rational. I mean, give me a break. They did rats, even rats, a rat's rational. But the contrast with Sippel did a brilliant job. He took university students. I'm going to assume you guys are rational, generally speaking. Sorry about that. And give them a budget constraint and a set of 8 commodities they had to choose from. And these were the commodities. You could watch a video clip for 30 to 60 minutes. You could play a computer game, read a magazine, drink Coke. It's basically what you're going to do chilling out on a Friday, okay, when you can't afford to go out. And they got an unlimited time to choose which ones they want. The test was repeated 10 times. And then one of the 10 was chosen at random that actually consumed that in the next hour. So the students actually really wanted to. They got random elements in what they were presented with, the price patterns and so on. And they said, "Oh, I really hope I get that one." Out of the 10 bundles which they were given a chance to choose. So they go through, and what was actually being done with all these various bundles of relative prices and incomes was testing what are called the axioms of revealed preference. Great acronyms here, WARP, the weak axiom of revealed preference. I think that predates Star Trek. So if A is greater than B, like if you prefer A to B, you'll never prefer B to A. That's the weak axiom. The other one, the strong axiom, the SARP, if you prefer A to B and B to C, then you'll never prefer C to A. That's the formal definition of the person maximising the utility. What's called GARP general axiom of revealed preference. If you prefer A to B and B to C, then multiplying the prices around will get you a condition of the relative cost of the two items. Okay, so it's more, again, if I took this stuff seriously, I'd go to it in detail for you. But it's saying something about the cost of buying the items. It's a way of quantifying the relative, your willingness to pay for those goods, and therefore the utility you're receiving from them is to some extent more quantified by including the prices. So this is the sort of stuff that was going on. If you had A and B were both affordable, and you choose A when you can afford B, then A must be on a higher indifference curve. Okay? That's the first test. So you should always prefer A to B. And with budget Y, A is clearly better than B. So you should still choose A even if there's a different budget line, because A is preferable to B. Now, they didn't do it. There's a bunch of 12 university students. 11 of them breached the rules. So either all the university students bar one are mad, which is fair enough sometimes, but it wasn't what he was expecting. So he reran the experiment. Here's the 11 out of 12 violated SARP and WARP, 5 out of 12 violated GARP. So he did a second experiment, I think napoli with the entire lecture group, hoping to get, maybe it was an aberration of a particular tutorial group. He still got a majority of violations of all these axioms. He went through a very, very careful, very good paper. I do recommend. Have you read the paper yourself?
Yeah, I read it.
It's good, isn't it?
It made you laugh. Yeah.
Pardon?
I laughed.
Yeah. You can see how hard he was working. He seriously believed this stuff at the time, and then by the end of it, I have real respect for that, because he started with a set of beliefs.
He gave every chance.
Every chance to make it work, and he finally realized it just doesn't work, and we should abandon our ambition of taking over social sciences because what we think is a sensible, and that's in fact wrong. So a lot of respect for this guy. The way you interpret it is saying it's not too favourable, and that's classic English understatement even for a German. He said there are a low number of inconsistencies. Median was 2 out of 45 of the various combinations, but the average was higher than that. And but he said they were trying to select something. They actually were, from what he could tell, trying to maximise their utility. Okay? From their point of view, they were trying to get the best bundle for themselves. So they really were not just making random choices. They were saying, this is what I prefer. A lot of time, 30 to 40 minutes. He said, well, how serious are the violations? Well, he had this thing called the Aggregate index, the price times quantity index I showed you earlier. And he said, if you consume A where B is affordable, then you can use this formula to weight just how big the difference is using a thing called E. And what E does is like having a thicker indifference curve. So if you have very, very thin indifference curves, then when you draw it, you might find that C is preferred to B is preferred to A. So I draw this sort of thing. There's A, there's B, there's C. They're really close together in quantity, and with thin indifference curves, they're going to be on different indifference curves. But if you say they've got thick indifference curves, which is sort of a comment about our capacity to process information, then with the thicker their difference curves, you might say A and B and C are all the same. Okay? The trouble... I don't want to be talking to somebody on Skype now. That was a Skype noise coming through. But what he then found is once he had E above 0.95, random choice appeared rational. And when it went between 9, random choice was more rational than what the people actually did, which is a violation of the whole idea of rationality. So that thick indifference curve just failed to save the theory, and that's again one of those really careful attempts he made to try to make the model work. So he finally said that when you had this with a low level of E, the thickness of the indifference curves, then the random stuff violated the principles less often than the students themselves did. So at the end of all this, he said the evidence is at best mixed. It's like, you sort of, I believe the Titanic may have sunk, Obviously, it's on the bottom of the bloody ocean. So he called the universality of the maximising principle into question, which is a good starting point. This is the sort of thing economists should have done and said, oh dear, our basic ideas didn't work. How can we elaborate? What can we change? That would have been a proper scientific process at that point. Because you say, well, does this mean people are irrational? No, what it means is the definition that economists use of rationality is irrational. I want to take you through as to why, because look at the basic assumptions. You have this completeness, transitivity, non-association, and convexity. And if you look at completeness, that's saying that you can work out, given any combination of shopping trolleys, you can say which shopping trolley you prefer. Now, if you have just 2 items in your shopping trolleys, bananas and biscuits, and there's only a small number of combinations, then it's pretty easy to make it up. So imagine we have like between 1 and 10 biscuits. To put numbers on these axes now, which they never do. Between 1 and 10 biscuits and 1 and 10 bananas, and then I've got an income. There's only 100 combinations to look at, between 0 and 9 actually. And some you can ignore because they're well outside your price range or well inside your price range. But there's some you can't ignore and try to work out which rise and which indifference curve. There might be about 10 combinations you have to look at. That means 10 budget sums you need to work out whether you can or can't afford them. 10 comparisons of utility. You're looking at 10 out of 100 shopping trolleys. Okay? And that's pretty easy. I can pick that one. That's easy. But what when you include a third item, like for example, you want to buy some coffee as well? Okay? How do you do it? Well, you can't do it with a 2-dimensional diagram. You've got to have 3, and 4, and 5, and 6, and 7, and 8. And that's what you get is an exponential scaling, super exponential scaling in the number of combinations. So with 2 commodities there's only 100, with 3 there's 1,000, with 4 there's 10,000. Okay? It gets out of hand very, very rapidly. With simple you have 8 commodities, which is 8 dimensions. Now, even if you discretize it and say you can only choose 0, 15, 30, 45 and 60 to give you 5 combinations, that gives you 5 to the power of 8. Now, we're very bad at exponential numbers. Anybody get what 5 to the power of 8 is? That's about 300,000, 400,000. So you have 400,000 shopping trolleys to choose from. Okay? That's a pretty big parking lot. Is it easy to work out which one you prefer? When there's 8 different commodities in it? Forget it. Okay? These are the sort of combinations you can go, and there are literally virtually 400,000 such combinations. So you simply can't. Okay? You'll likely just focus on the things you most like. I'll take that one. That one's got more of what I like. I'll take that one. Okay? And therefore, if you actually try to assess whether you're rational on the basis of the precise decisions about, forget it. You're going to come out as irrational. You're not irrational. You're making a decision before you starve to death. And I want to quantify just what sort of length of time we're looking at, because you've got a bewildering array of, even with 8 commodities and 5 combinations of them, 1, 0, 1, 2, 3 or 4. There's a bewildering range of choices you've got. Now, the hard thing about going shopping is not choosing what maximizes your utility. It's choosing something and getting out before the shop closes. Okay? It's even, when you look at it mathematically, it's getting out before the universe ends, if you try to do the sort of utility maximizing stuff they talk about. So imagine there's only 100 items in a supermarket. Have you ever been in a supermarket with just 100 items? Okay? So I'm trivializing, again, it's the scale of this stuff is kids' play stuff. And we're living in the real world, so you've got to say, does this scale to the real world? Well, if you bought either 0 or 1 units of 100 items in a supermarket, there are 2 to the 100 combinations, whether you do or do not buy. That's all you're making. Do I buy or do I not buy these items and fill my shopping trolley? How many potential shopping trolleys could you have? That is 1 million trillion shopping trolleys. Okay. You're just not going to do it. Forget it. It's an irrational definition of rational. And that's the problem with the neoclassical theory in general. It's a toy model. It looks good on a sheet of paper, it looks good on a textbook, but it can't possibly scale to reality because what's going on here is what's called an exponential complexity problem. And that's the number of combinations scales exponentially as you add additional ones. If it's just the linear adding it together, this would be easy to do. But it's the fact you've got to go 1 dimension, 2 dimension, 3 dimension, 4 and so on to the power of the number of choices you're looking at. And it's 2 to the n problem to actually decide whether you do or do not buy each item in a 100 item shopping supermarket. There's 2 choices: do or do not buy each unit times 100 to the power of 100 times. Okay. Now, if you put that into a computer and said, "Well, find the maximum utility for me," just mention they made an app you could put on your iPhone. And if each calculation took the computer 1/10 millionth of a second, then the length of time it would take to work out the optimal bundle is 3 to 5 years. If 50 commodities. So half, I'm down to a really small corner shop now. So if you're a neoclassical consumer, you'd been there for 3 to 5 years before you made your purchase. They wouldn't need to kick you out, you'd die in the meantime. When you go to, like imagine our brain, is our brain bigger than that? Well, our brain's got 10 to the 11 neurons, which is a fair number, 100 billion, and each one connects to 1,000 others, so there's lots of processing power inside there, and everything is passed by voltage spikes, which take about 1,000th of a second to generate a spike. And you can imagine that what we have in our brains is simply completely devoted to working out revealed preference. Let's say it took 5 to 100 milliseconds. That's how long, in terms of actual calculations. When you look at something, it takes you between 1/20th and 1/10th of a second to work out what you're looking at, to make the recognition. So 100 perception would take about 5 seconds. So if your brain was like a massively parallel processor for this, where each neuron was devoted to working out utility for a particular commodity, and if every decision took 5 seconds, then you'd output 5 by 10 to the minus 11, which is quite fast. Okay, so you would therefore take in that situation a mere hour, 2/3 of an hour in 50. There are 50 commodities. That's bearable. But what if you go to a large number of commodities? You get towards 100, okay? It'll take you 80 billion years to make a decision, which is 6 times the estimated age of the universe. I like to ridicule this stuff because it's just, please don't take it seriously. But this is what neoclassical economists have in their head when they think they're being rational about how they argue that consumers make decisions and how markets function. So it's what's called an exponential problem. This is where you should really learn some computing to get an idea of what problem solving is like. So it's the number of comparisons you have to make is 1 plus the number of units you're buying. So if you're buying 1 unit, there's 2 to the power of the number of commodities you're looking at. And in the 50 commodity shop, that gives you that many comparisons, 10 million billion different combinations. In other words, it's not trivial. The neoclassical attitude to this would be, oh, that's just a trivial. No, it's not. When you look at the numbers, it's huge. And they're non-computable. And there's wonderful, some of the writing in computing textbooks is really quite good. And they'll talk about whether you can or cannot solve problems. And when you're looking at like simple procedural stuff, quite straightforward to do. Sorting, finding the fast way to get somewhere, what's called the travelling salesman problem, they become simply non-computable. You cannot find the optimum. And it is beyond any possibility to find the answer. So this is looking at some of the levels of combinations necessary to choose, like if you're adding up numbers, you want to add up n numbers, then there's as many additions as there are numbers. If you want to sort them, then you get a squaring going on. For the utility combinations, it's 2 to the power of the number of goods you're looking at. If you want to 0 to 3 items, it's 4 to the power of the number. So if you have 1 billion comparisons a second to make those comparisons, a shopping trip in a standard supermarket would take the age of the universe times the age of the universe. So it's non-computable. And then this is what we should be saying if we're actually trying to talk about how people behave. We should say, well, we presume they make computable decisions. Therefore, they can't be doing what neoclassical theory says they're doing. They've got to be doing something else. So completeness is false. And in fact, there's one of the best contributors to economics was von Neumann, who's a mathematician of first order, literally not just best for his time, but one of the best of all time. And von Neumann, when he was trying to find a replacement for indifference because he thought they were stupid, and he came up with an alternative method for deriving a numerical estimate of utility. But the one thing he said he wasn't sure about, he didn't think it through properly, was completeness. And he said, if my thing might fall over because of the problem of completeness, but if my idea falls over, then so does the neoclassical idea anyway. Okay. I wish he'd worked it through more thoroughly. It wouldn't have been inflicted to some parts of game theory. The completeness is this one about being able to say whether you prefer one shopping trolley to another. Okay. Now, in reality, you simply can't. The computational load of that is just too great. So you can't compare those bundles in finite time. So all the others fall over because of that. Because without completeness, none of the others will work. So what do? We still go shopping. You know, how long do you take in a supermarket? Half an hour? That sort of thing. Okay. What you're doing is you're choosing a satisfactory bundle. You're not choosing anything that maximises utility. You wouldn't know it if you fell over it. You prioritise. You will buy milk before you buy soap, God knows. But there'll be things you think which are more desirable than you can ignore. If you can't afford some stuff, you don't buy it and even think about it. Habit. You go back and buy the same stuff you bought last week. And you categorise. You buy fruit. You buy toiletries, etc., within it. And that drastically reduces the dimensionality of the problem you're looking at. Okay? And you've got your own physical needs. It's not a case of maximising utility, it's staying alive. Okay? So some things have absolute priority. You're not going to ignore food. Okay? So that's drastically reducing the dimensionality, making a sensible decision, walking out again. So you can't utility maximise. It's just not possible. So, and this is one of these texts that I really enjoy in computational theory. If the brain is performing computation, it should obey the laws of computational theory. So what are the laws? Computability and complexity. Paraphrasing them as follows. You cannot compute nearly all the things you want to compute. And that's, you've seen an example of that. The things you can compute are too expensive to compute. These are the sorts of problems which people doing actual computational work have to deal with. How do I make this thing computable in finite time? How do I make a worthwhile comparison, because I can't make a perfect one? And that's what we should be applying again when we're thinking about the way our own brains behave, rather than the neoclassical idea of optimization. Optimization is simply impossible for most interesting problems, including shopping. So you can't characterise behaviour using this idea of indifference curves and budget lines. It's computationally impossible. And what true rational consumers are doing is making a satisfactory decision in a finite period of time. Okay? But let's just ignore all that. This is what I've got to keep on doing in debunking economics, and say, even if it did work, can you derive a market demand curve from it? The answer is no. And I regard this as the greatest own goal in economics, because this was not what the economists were trying to achieve. They were trying to prove that, remember I said initially, when you vary the relative price, you don't vary the income. So I vary the price of bananas and I don't assume that it changes your income. But once I do include the fact that there are banana producers in the entire economy, and I do change the price of bananas, I do change their income. So I can't assume that pivot point doesn't move. Once you do that, the question is, what sort of curve do you get when you start aggregating where that point moves? And this is the problem that Neoclassical set themselves. So pretending it works, how do you go from a single consumer to a market demand curve? Now, you saw Mankiw saying you simply add them up horizontally. Okay? And most Neoclassical economists probably think that's okay, because they haven't thought deeply about it. And they think if anybody has thought deeply about it, they've solved the problem and it works, so I can continue doing this stuff and not have to worry about it. So you'll see Mankiw. This is the Mankiw example again. Horizontal sum, nice and easy. But the key assumption in deriving the demand curve from the idea of indifference curves is that changing relative prices did not change income. But when you start looking at everybody in the economy to derive a market demand curve, what's the demand for bananas in this market? Okay? That market's going to include people who produce bananas. Okay? And then every other commodity you can think of. So when you change relative prices, you change relative incomes. If bananas get cheaper, banana producers can afford to buy less of everything. Okay? If they get more expensive and the sales go up, all these issues become important because price determines incomes. And that's not just in their theory. I think that's a reasonable overall statement. It isn't just neoclassical theory that would agree with that. So what you've got in deriving a demand curve, this operation, the pivot point doesn't move. And then you can drive your downward sloping demand curve for the individual, because you've made the reasonable assumption that changing relative prices for an individual consumer does not change that individual consumer's income. But once you've got more than one consumer, in trying to work out a general curve, you can't do that anymore, because prices are the source of incomes. So, with many consumers and many goods, changing the price of one commodity changes real income for all consumers. So the budget constraint doesn't stay in the same place when you change relative prices. And a bunch of neoclassical theorists, starting with a guy called Gorman, who wrote before I was born, I might add, published in 1953, year of my birth, this particular paper, and they asked themselves the problem, under what conditions will the market demand curve have all the conditions we impose on an individual demand curve? And that is downward sloping. Okay? Fundamentally, a downward sloping is all the stuff they could prove about the downward sloping curve when they actually do it in the textbooks is with an individual, isolated individual. Under what conditions does the market demand curve have exactly the same properties that the market demand curve slopes downwards? And it's called the Sonnenschein-Mantel-Debreu conditions, after the second group of people who discovered this long after Gorman had done it. And the idea of the law of demand, the fact that the idea that demand will necessarily rise if relative price falls for a particular commodity, once you do the Hicksian compensation, that involves income effects, compensating for the change in income. For an isolated individual, where you presume their income doesn't change when you change the prices. Now you're trying to do it for everybody in general. What actually happens? Well, what they found, and this is the way it's stated, we proved that every polynomial is an excess demand function for a specified commodity in some end commodity economy. What the hell does that mean? Anybody tell me? What's a polynomial?
A graph, so it could be any shape.
A graph which is a plus bx plus cx squared plus dx cubed plus out to n times x to the n, or z times x to the n. So it's a polynomial, and you can fit virtually any curve with a polynomial. Okay. So the characteristics of a polynomial, when you actually draw them, is first of all, if you actually draw a curve on a sheet of paper and say, can this be fitted by the polynomial? It must be continuous, so you can't take your finger off the curve paper. It can't cut itself, so you can't do a loop. Okay? And you can't have two values on the vertical for one value on the horizontal. Okay? Those are the rules. Otherwise, anything goes. Okay? So, if I did this, that's a polynomial. Is that a downward sloping demand curve? No, but it's a legitimate market demand curve for any commodity, given the fact that when you change relative prices, you change incomes as well. And that means that what they draw for the market demand curve is not valid. The valid shape they can draw is something curvy. So even if you're summing up individual demand curves that look like this for Crusoe and Friday, that's what you're going to get for the island. I want to take you through what's going on here. What's the logic behind it happening? It's an accidental case of proof by contradiction. Who hasn't heard of proof by contradiction? Okay. That is. Remember, I mentioned last week the idea of a heuristic assumption. Okay? You assume something that you know is false to prove a later proposition, which is more general. That's fundamentally what's going on with the proof by contradiction. So you start by assuming that market demand curves do obey the law of demand. And you derive conditions under which this is true, and you find you contradict your initial assumptions. That's what's going on here. So what you therefore prove is market demand curves do not obey the law of demand. And this was actually first done in the days of Pythagoras. You know all of Pythagoras, of course. Well, back in those days, somebody who could do mathematics, you were part of a cult. Okay? And there was a cult of Pythagoreans. And one essential belief they had was that all numbers are the ratios of two integers. Any number you choose, for example, the length of the right angle, the triangle of the hypotenuse of a right angled triangle, that is the ratio of two numbers. Now, the person who first proved that was not true drowned for his troubles. He believed to have found it. He was actually working with the ratio of the intersections of a pentagon, so a 5-sided object, and he worked out the ratio of the lines and worked out there was no consistent pattern. Because if you have one pentagon and you join all the points together, you get another pentagon. Okay, and you do that, you get another pentagon. And he worked out the geometric sequence and it never converged. And his friends, when he made the mistake of working it out on a ship in the Mediterranean, and shortly after he worked it out and showed it to all his colleagues, he was thrown overboard. Okay. But let's choose an easier one than a polygon. Let's just choose the square root of 2. So you all know that the square root of 2 is an irrational number, meaning it's not the ratio of two integers. Here's how you prove it. It's quite simple. You start with an assumption and you get a contradiction. Therefore, you prove that what you assume to begin with is not true. So if the square root of 2 is a rational number, that's what you're assuming. You assume it's a rational number. Then there are two integers, a and b, which are the smallest numbers for which it's true that a divided by b is equal to the square root of 2. Okay? So that's your initial assumption. Now, what do you do? First of all, well, you start with that, and you assume that a and b have no factors in common apart from 1. Okay, they're the smallest possible numbers for which this is true. So a and b can be divided by 1, but no other number. That's where you're starting with your assumption. So you're making a heuristic assumption here that that's true. What you do, first of all, you square both sides. You now get a squared divided by b squared is equal to 2. Then you multiply across by b squared and you get a squared is equal to 2b squared. Now what does that tell you about a or b? We're talking integers here. What is a squared? What must a be? What if, say, b is 3? Okay. Then what is a? 3 squared is 9. 2 times 3 squared is 18. Is a an even or an odd number? A is even, isn't it? Okay, no matter what you do, if that's true, then a must be an even number, which means a must be divisible by 2. Now, we can now express a, therefore, as being 2 times some other integer. So a is 2 times c. And I can feed that into the previous equation, say a squared is 2 times c squared, which is 4 times c squared. When I multiply this, when I square 2 times c, I get 4 times c squared. Now substitute that back into the equation for a squared above, and what you get, that's the one up there, you get a squared is equal to 4 times c squared, which is 2 times b squared. So now, divide by 2, and I get 2 times c squared equals b squared. What do I know about b? It's an even number. So a and b have 2 in common as a divisor, which you assume they didn't have. So you've proven that the square root of 2 must be irrational. Okay, that's the basic idea for proof by contradiction. So what I want to show is that what's actually happened with this, finding that market demand curves can have any polynomial shape at all, even if you're starting from individual consumers with downward sloping Hicksian compensated demand curves. It's basically a proof by contradiction. So, let's see, now back to the Pythagoreans. They did drown the guy, we believe. It's not known for sure, but we do believe that they drowned him. But they ultimately accepted there were irrational numbers. Now with irrational numbers, you can solve many more problems than you can with rational numbers. Then you got the idea of complex numbers, which were numbers involving the square root of -1. They were invented before we discovered electricity, but they're essential to handling electrical systems. So a huge part of the advances we've made in mathematics is by reaching results like this, finding you've got to assume something you didn't believe was true beforehand, generalising your understanding and getting the world in which we live. Neoclassical economists, rather than burying the person, they didn't kill Sonnenschein-Mantel-Debreu, they just killed the result. Okay, they buried it in obfuscation, and I want to go through and show what is actually logical. So you derive this, the individual downward sloping Hicksian compensated demand curve by taking an individual with a well-behaved utility functions, they actually obey those axioms of revealed preference, the vary price of one commodity while you keep all others constant. Okay, so you do this. That gives you your downward sloping demand curve. Then you do your Hicksian compensated thing. But first of all, what you're doing here is you're assuming that pivot point doesn't change as you change the income. That's your first stage. That stays fixed. Then when you do the Hicksian compensation, you presume you can move that budget line back and reach a point of tangency to give you that necessarily downward sloping curve. So what this the Hicksian compensated demand curve now is telling you is the slope of the indifference curve. You've got a single indifference curve for a single individual, and you can get away with that as an assumption. And therefore you get this law of demand, the downward sloping demand curve. Now what the SMD research is saying is, does that apply when you aggregate to get market demand? And the answer was no. So the logic here is that the individual demand curve is ignoring the impact of changing prices on income. But once you say that prices determine incomes, then changing prices changes income distributions. So that's now works through the logic. Imagine you have a market where there's different income sources. You've got two consumers with different sources of income. One might be a worker, the other's a capitalist, or one might sell Nikes and the other sells computers, something of that nature. They've got different tastes. Okay? Otherwise, there's only one consumer. So your different consumers have to have different tastes and different income sources. On the commodities, and also taste must change with income. The more you earn, in general, you should change what you buy, because if you buy stuff in exactly the same ratio, what you're effectively saying is there's only one commodity. Okay? Get the idea? You're not going to buy the same amount of toilet paper when you're a billionaire as you were relatively when you were a student. Okay? Well, Richard Branson almost died a couple of days ago. Did you see that? He apparently almost killed in an avalanche. It's a little story, a feature story on, one of the usual pulp stories on City Extra, whatever it's called. I'm sure his consumption of pizza is rather different now than what it was when he was starting out running his first record shop. So taste must change with income, and you have to have different income sources and different tastes between consumers. So imagine you've got Robinson Crusoe and Man Friday, and the two commodities are coconuts and bananas, so making it as simple as possible. Crusoe owns all the banana trees, Friday owns all the coconuts. They've got two different income sources. Coconuts are a necessity, so you buy them, but bananas are the luxury, so the higher your income, the more you're likely to increase your consumption of bananas. And Friday happens to prefer coconuts more than Crusoe does. So I've got those differences there. And start with some arbitrary ratio of prices. So we have Crusoe and Friday. And I'm drawing in Crusoe's indifference because I didn't try drawing in except for Friday, but imagine they're there. So there's your initial relative prices. And you keep aggregate income constant, so there's no change in the number of coconut trees or banana trees on the island. Now you consider a lower price for bananas. So now the slope is flatter. Now, Crusoe is the banana owner. So his income is going to fall. Friday is going to relatively rise because he owns the coconut, so it's cheaper now for him. So the point of tangent, the point on the vertical axis for Crusoe is lower. The point on Friday is higher. So the market demand for bananas can fall because of a lower price for bananas, because it causes a distribution of income change. Crusoe's income has fallen, Friday's has risen, but Friday doesn't like bananas as much as Crusoe does. So the price of bananas falls, demand for them falls as well. Then if you have the idea of changing the income, the Hicksian compensation trick, well, that keeps relative prices constant, but increases income equally. Now imagine you plant more banana trees and more coconut trees on the island, so you increase the number that they're each producing. Well, here you start with your initial indifference curves again and your initial budget line, and then you push that budget line out, banana demand will rise more than coconut demand. So Crusoe's income will rise more than Friday's because both of them want to buy bananas more than they want to buy coconuts. So Crusoe's going to be better off. So you can't compensate for the income effect of the price change. What you do will change the distribution of income again. And this is the point. Any change now is changing the distribution of income, change in prices, change in incomes. So you've got this problem that because one's a luxury and the other's a necessity, and once you have two commodities, you will define them that way. Okay, one will be more likely to consume more of one than another. Has anybody seen the Tom Hanks movie called Lost or something like that? Well worth watching. It's a very, very good show. He's wrecked. He's not DHL, but one of those courier companies, and his plane crashes, and he's the only survivor and ends up on an island. And the first thing he wants to do is to open coconuts. And boy, does he get sick of coconuts after a while. And then he tries to work out other ways to open other things. But something will be a luxury, something else is a necessity. As soon as you've got two commodities, that's the situation you have. So what you get is the only way to avoid this. First of all, is to assume that all consumers have identical tastes, which means you only have one consumer. And secondly, assume that tastes don't change with income, which means you have only one commodity. That is a contradiction. Okay? So what you've shown is, even if you start from having individuals who've got those Hicksian compensated demand curves, when you add their demand up, you get any old shape at all. Okay? So you have two consumers with different tastes, two different commodities. You prove by contradiction that the law of demand does not apply to market demand. Now that's not how neoclassicals express it, of course. If they did, they might have got somewhere. But they really wanted that to be the actual outcome. So they start defining all this stuff as stringent conditions for market demand, because which we assume apply in all cases. Okay? They're stringent conditions, they should only apply in some. Now, these stringent conditions are like stringent conditions that rule out the existence of irrational numbers. You can have any triangle that you like, so long as it doesn't have, so long as it has an integer value for its hypotenuse. So, Sonnenschein and Schaefer and Sonnenschein say this: preferences will, the market demand curve will obey the law of demand when preferences are homothetic and when the distribution of income is independent of prices. Well, that's a contradiction of one of their essential pieces of logic. A large part of the neoclassical case is to say that price determines incomes. Okay. Gorman, I love this one. He said that, have you heard of what are called Engels curves? Okay. Poor old Engel gets bashed around by neoclassicals, they use his name all the time. This is showing what income, if you change income, what's going to happen to your demand. So Engels curves are supposed to show whether something is a luxury or a necessity. Okay. What he's saying is that not only do they have to be neither luxury nor necessity, they've got to be parallel straight lines for everybody in the economy. Okay. What the hell does that mean? Well, these Engels curves are supposed to show how consumption of a good changes with income. And you have basically three potential cases. A luxury consumption will rise relative to other goods as your income rises. A necessity consumption will fall relatively. And a given good, consumption will fall absolutely. The more you get, the less, in general, the less you consume of potatoes. A classic example. So graphically, this is a necessity, reducing consumption over time. Okay. This is a luxury, increasing consumption over time. An inferior good, declining consumption as your income rises. Okay. Now Gorman said none of those can be the case for all commodities. None of them. Instead, what they've got to look like is this. Neutral. Increase the income, you can draw a straight line for the consumption of those goods relative to everything else. Now, that means that if you say consume one pizza, one Coke and no Rolls Royces when you're earning $100 a day, and you become Richard Branson, and you're getting 10,000 a day, that'd be trivial in his terms, I'm sure. You consume 100 pizzas, 100 Cokes and no Rolls Royces. Nonsense. Okay. And it gets worse. Because your curves have to be parallel to everybody else's, there's Joe Bloggs, so you can draw this set of Engel curves for Joe Bloggs, and Bill Gates has to have exactly the same slate. And it gets worse again, because they say personal Engel curves have to be parallel straight lines for different individuals at the same price, but neoclassical ignore credit. Okay? They don't take into account lending, certainly at the level of micro-theory they don't. So if you have zero income, you're going to buy zero everything. Okay, so all these parallel lines are passing through the origin. Now, if parallel lines pass through the origin, they're the same line. So your model of what's supposed to be different individuals and different consumption patterns is saying there's one person consuming one commodity. Well, let's talk about the relative prices of one commodity. Let's talk about the sound of one hand clapping. Okay, there's a certain Buddhist, Zen element to neoclassicals they're not even aware of. So The idea is that that's your income pattern, and there's going to be everybody's Engels curve. If that's the relative price pattern, that's going to be the Engels curve. It's nonsense, unfortunately. It would be really nice if it worked, because the economics and the economy would be simple, but unfortunately, it's all nonsense. So you can't even derive a market demand curve that makes any sense. You've got all individuals having the same preferences, so there's just one individual. Remember, you've all seen Life of Brian? Okay. And you're all consuming the same thing. There's only one good. So there's no green bottles. Okay. So the only way you can get them being downward sloping is if there's one consumer consuming one commodity, which is nonsense, because then there's no point even talking about a demand curve. Okay. So it's proof by contradiction that this stuff doesn't work, even if individual demand curves do work. So that's, again, repeating the logic here. They can have any shape at all. So when the economists draw curves like this, that's illegitimate. On their own theory, what they should be drawing is something like this. Now, if you do that, how can you say what the price is going to be for different quantities? You can't do it. Okay. So you're talking about a point of equilibrium there. When you draw a supply curve through that, you're going to get multiple intersections. It just can't be done. So the proper response should have been to say, well, we can't guarantee market demand curves slope downwards, so we can't do supply and demand analysis. And the real point, I gave this talk once, or part of a talk like this, and I was on stage with Deirdre McCoskey, who's a famous sort of progressive neoclassical economist. And she said to me, oh, yes, Steve, but surely you're not saying market demand curves slope upwards. And I was so flummoxed by how, pardon me, Deirdre, stupid the comment was that I didn't make a proper response at the time. But I wasn't saying I just disagree with the argument that demand will fall for most commodities if price fall. I'm simply saying neoclassical economists can't explain it. Their theory does not have an explanation. So the question is, what are they omitting? And what they're omitting is the distribution of income. They talk about a consumer. They don't talk about a worker and a capitalist. They're leaving out different classes, they're leaving out social aggregation. And in fact, what they've done by this is prove that if you don't have social classes or some idea of the distribution of income in your theory of consumption, you can't explain an essential part of the theory, which is the demand curve. And this is the point that Alan Kerman first reached. Alan's become a good friend over time, I'm pleased to say. So you can't do what neoclassicals do and ignore the distribution of income. Now, if you look at the classical school, Marx and Ricardo and Smith and so on, they talked in terms of social classes. They talked about workers, capitalists, landlords, bankers, and so on and so forth. This is Alan's reaction. If we are to progress further, we may be forced to theorise in terms of groups who have collectively coherent behaviour. So it doesn't make any sense to lump you with Richard Branson. But it does make sense to lump Richard Branson with Rupert Murdoch. I'm not sure they'd actually enjoyed the experience, but, their incomes are similar. And therefore their consumption, they're going to be consuming more Learjets than anybody in this room, okay? So therefore you can get that type of income distribution effect, and you can say, well, as Learjets get cheaper, somebody in this room might finally afford one. So the idea we should start at the level of the isolated individual is one we may have to abandon. And that would have been a sensible reaction to this theorem. Now, unfortunately, that's not at all what happened. Instead, you got this idea of the representative agent. So I've shown you Schaefer and Sonnenschein before. Schaefer and Sonnenschein, I haven't had a drink I need to get some water to cut my vocal cords from freezing out. But what they say is market demand functions need not satisfy in any way the classical restrictions that characterise consumer demand functions. Now, that's true, but it's ambiguous. What does that mean? Okay. The importance of the above result is clear. Strong restrictions are needed to justify the hypothesis that the market demand curves have these. What are they talking about? They're talking about being downward sloping. Why not say it? Okay, that's the key thing they're talking about. So only in special cases can an economy be expected to act as an idealised consumer, which means only in special cases can you use the idea of a representative agent to model the entire economy. Those special cases, in terms of mathematics, are the same as a world in which no irrational numbers exist. There is no such world. Okay? So that's bad enough, even though they I mean, you imagine what's going on here. They were hoping they could do the heroic, we've found the proof that market demand curves decline. We've done it. No, give me the Nobel Prize. Holy shit. I'm not going to get the Nobel Prize for that, am I? I better become a university administrator, which is what one of these guys did after he proved this result. Now, it's worse in textbooks. This is my favourite, Varian, Hal Varian, who now these days works for Google, I think, said it is sometimes convenient to think of the aggregate demand as the demand of some representative consumer. Now, if you look at the Varian text, it's full of mathematics. Okay? It's an exercise in math. I call it exercise in myth, but it's mathematics, lots and lots of mathematical terms all the way through. And he delights in taking you through and torturing you to work out various things about Slutsky equations and stuff like that. But in this book he says, the conditions are rather stringent and are beyond the scope of this book. Just take it up, just trust me. Trust me. I've got a bridge I'd like to sell you. Okay. That's Varian in 1867. Now, what I found hilarious was, in the second edition, he said this demand function can in fact be rationalised by a representative consumer. Now, funnily enough, the word rational means sensible. The word rationalised means I'm doing some bullshit here. You use that use in English? Rationalised means I can make an excuse that sounds valid, but I know it's garbage. Okay? Third edition, generated. Much better. Imagine the word's inconvenient. You've got to find a better word that obfuscates better than the previous word you used. That's what he did. Not particularly impressed with that. Now, undergraduates are even worse. They didn't even discuss it. So this is one textbook I was using back in the early 2000s when I found this particular problem. Mankiw, as I showed you, had this little idea, a nice simple idea, just add off horizontally, no discussion at all of the income effect. So most of them aren't even aware there's a problem, or they think it's been handled by the representative agent assumption. And of those that they do know about it, you get these crazy stuff like the Paul Samuelson paper I gave to you. So this is Samuelson's textbook. I think he died by 2010. It's being reproduced by Nordhaus, 19th edition. Notice that the market demand curve is found by adding together the quantities demanded. Does the market demand curve obey the law of downward sloping? It certainly does.
Yeah.
Okay. All this like now. The funny thing was, I thought, what crap, and then somebody pointed out, no, Samuelson proved it. Oh, did he? The article I gave you to read. He thought he proved it was true. And this is, when I found this, Samuelson actually was part of the debate with post-Keynesian economists called the Cambridge controversies. And at the end of that, he honestly conceded he'd lost the debate. So that gave me, even though I criticised Samuelson all the way through, huge amount of respect for somebody who can do that. Okay? But this crap beforehand was just unthinkable. So he started by admitting there's a problem. What defence can we make when we're challenged about using community indifference curves? So using an indifference curve to describe an entire economy, which is what they do with modern DSGE models. For an entire country or group of individuals, what justification can we give? We said we might claim they're identical tastes. And that's conceding the problem. Or they have identical initial endowments of goods. So Robinson Crusoe and Man Friday both have exactly the same number of coconut trees and banana trees, so it doesn't matter. Okay, we're all workers and capitalists. I own major corporations and I work for a living. So there's no class distinction. Okay? Not very realistic, but it's an improvement over Robinson Crusoe. And then he says, well, in fact, you can derive a family indifference curve because blood's thicker than water. We can say that there's some sort of consensus within a family. So a family can aggregate all the income together and redistribute the income so that to keep the marginal social significance of every dollar the same. So mum and dad and they come home and the kids as well and they pool all the money together so everybody gets an ethically justified amount of money. That's a typical family budget. And then this bit, I couldn't believe this. The same argument will apply to society if optimal reallocations can be assumed. This is America, guys. Okay, it's not the Soviet Union. And we haven't got Uncle Joe at the top, but that's literally a rigorous proof, a rigor mortis proof. Okay. And this is the sort of stuff that the textbooks will then look back in and say, here's the justification, Samuelson's proven it. Look, he said he proved it, he must have proven it. What the hell was he smoking? It's just to me, beyond belief. And the top textbook these days, the Mass-Callel. Did you check Mass-Callel?
I haven't checked it.
For your essay, find it, okay? And then look at the Mass-Callel versus Paul Samuelson, and you'll enjoy it, okay? I'll victimise you well. You'll enjoy that one. So it's Mass-Callel saying we can compute meaningful measures of aggregate welfare using, when can we compute it for individual consumers? When there's a fictional individual whose utility maximisation problem, when facing the entire society's budget, the whole GDP, would generate the same as the entire society's aggregate demand function. So we think there's one person whose utility maximising venture we can all agree with that, what maximises utility, given what that one person chooses. And there must be a social welfare function which expresses how accurately individual utilities have to be compared. So we have a system which we all agree that allocation is the best possible one. Nobody's arguing. Nobody's fighting over the distribution of income and wealth. Okay. This one. Let us now hypothesize, and look at this, a benevolent central authority. Holy shit. Yeah. Here we are assuming we've got a socialist economy, a happy socialist economy, and we're modelling capitalism. Yeah. This is, when you look at it, beyond belief, but this is what they're doing. And to me, this is a tragedy, an intellectual tragedy, because if you think about what they were trying to do, and it's a justified ambition. They were trying to solve the problem, is can a market economy reach an equilibrium allocation so that all markets are in equilibrium? Okay? And they would have liked the answer to that to be yes, whether you're working with smart people or dumb people. That would have been their preference. You know, yes, this market reaches equilibrium, and it doesn't matter if there's stupid people out there doing silly stuff, the market overall cancels all that out. That's what they would have liked to have. Now, they didn't get it, but they were so wedded to this vision of equilibrium applying in all markets at once and not needing any coordination, like an anarchist, capitalism is an anarchist paradise. They were so wedded to the vision that they were willing to distort their picture of the individual to get that result. So rather than saying, look, you know, it doesn't matter how stupid people are, the market will rule and we'll reach equilibrium, they say, we assume everybody's a rational agent. And we define rational as being able to accurately predict the future, which is that's literally how they define the word rational at one point. So it's a tragedy in some ways. Again, it's a bit like the Pythagoreans. They believed that all numbers were the ratio of two integers. They were not at all happy to find that wasn't the case. But they grew up. Economics doesn't. It's willing to assume a benevolent central authority in a model of capitalism. Okay? So they think that, you know, the majority don't even know it's a problem. Some of the rest of them think it was a problem, but the representative agent solves it. Others make these sorts of interpretations, and here's Gorman. I love this one. And this is the very first time it was realised. The necessary and sufficient condition quoted above is intuitively reasonable. It says, in effect, that an extra unit of purchasing power should be spent in the same way, no matter to whom it is given. So if Bill Gates walked past a homeless person and throws $1 into their pocket, that homeless person will go and buy part of Leonardo da Vinci's Coda, which is the main thing, apparently, that Bill Gates likes spending his money on. Okay, and if it goes the other way, and you know, if the homeless person gives the $1 back to Bill Gates, Bill will go buy some methylated spirits and drink it. That's intuitively reasonable. So it is just absurd, and again, varying, you know, no restrictions. And then he says, what is his way around it? Again, this is what most of them have learned. So I can't really criticise the majority of neoclassical economists because they take their textbooks on trust. And you should be able to do that. You should be able to trust that the books from which you're learning the discipline you think is a science are genuine. But because of these layers of trying to hide results they didn't actually want and not being very happy about finding something, say, express it in a way which is vague, and then somebody looks at it and says, well, I can get a step around, and somebody as Gorman can think it's intuitively reasonable to say that an extra $1 will be spent the same way to matter. Honestly. But here's the way it's put in Variant. He quotes Gorman. He says, we suppose all you, and notice this is the indirect utility function thing again, the idea of indirect price quantity reversal, take the Gorman form where the marginal propensity to consume good J is independent of the level of income of any consumer and constant across consumers. That is assuming everybody's the same. Okay. We can rationalise that, and then of course we get the idea of generating it later. So this is Kerman, Alan Kerman, in his article showing why this doesn't work. He has two individuals at different indifference curves. An A-puts bundle XA in a higher indifference curve than YA. B puts XB in a higher indifference curve. Combine the Azure makes the same aggregate choices. I'm going to jump to Alan's example is a bit complicated, so I'll show my drawing differently. What he shows is when you combine the two together, you get the representative agent preferring Y to X, whereas it was the other way around for A and B. They preferred X to Y. The aggregator prefers Y to X. This is a simpler example here. So you have, let's look at all other goods, and I've got two consumers there, red and blue indifference curve lines. The other classes, they're waiting outside. I'll make sure we finish in time today. So there's a budget line for both of them, okay, and there's the amount that the red consumer will buy, and there's the amount the blue consumer will buy, given the utility maximising behaviour. And then I take another relative price and income level, and there's the amount that the red consumer will buy about R2 and the blue consumer will buy about B2. And what you can see is that R1 is preferred to R2, it's a higher indifference curve, and B2 is preferred to B1, that's a higher indifference curve. Okay? Now, you can add them up by triangulation. I'm going to push out those incomes now and add the two incomes together. And I'm going to then triangulate the amounts that are being purchased to show what red's going to buy and blue's going to buy. So there's my aggregate consumer now, putting the two together. There's my aggregate indifference curves. There's the representative agent combination with 1. There's the combination with 2. And the utility of A2 is bigger than the utility of A1. But the red agent prefers shopping trolley 1 to 2. The blue prefers 2 to 1. The aggregate prefers 2 to 1 as well. So you can't even represent two consumers with a representative agent, let alone an entire society, which is what they do. And that's the basis of macroeconomics today, and I'll take you through that stuff in a couple of weeks' time. So the demand curve is sus. You can't have individuals being utility maximisers because the indifference curves don't exist. They're a fiction of economist imagination. Even if they did, you wouldn't get downward sloping demand curves out of them. So what went wrong? Well, this is an example of what's called emergent properties in complex systems. And I'll cover a bit of that in later parts of the lecture course. But what it's saying is that aggregations of even identical things do not behave. The behaviour can't be understood by understanding the individual behaviour of those items. So, for example, a molecule of H2O. What is that? What's H2O? Water. No, it's not. Water's a substance. Water's lots of H2O together at room temperature. Okay. So water is a property of a molecule we call H2O. Now, if you there's H2O inside this room. Okay. It's called moisture. It's in the air. It's a gas, effectively. If I heated it up, it might be steam. If I froze it, it's going to be water. If I freeze it under particular conditions, it's snow. None of those properties can be derived from the property of a molecule of H2O. It's the combination of the molecules together that give you those properties. So even water is an emergent property. The fact that it's, if you put an ice cube, the ice floats on top of the ice, that's an emergent property of the interaction of identical molecules under different conditions. So emergent properties are commonplace. You experience them every time you have a glass of water. Okay? It's that common. But neoclassicals are trying to do what's called strong constructionism. They're trying to start from the micro and build the macro, where the macro is consistent with the micro. Now that's not the real world. Macro aggregations are fundamentally different. So the market demand curve doesn't obey the law of demand. You don't get any of the outcomes they want to have at all. So methodological individualism, which is an essential part of the neoclassical paradigm, does not survive emergent property, which they themselves have identified but not understood. So the because part of one of the reasons this happens is neoclassicals are wedded to a vision of society in the same way that astronomers back in the 1500s are wedded to a vision of the universe tied up with God creating the universe and putting the earth at the centre. When there's fundamental sense, they're stuck with this religious perspective and they want to hang on to it. Whereas when physicists started to realise the existence of complex systems, they happily, that's supposed to be That's TIN, someone got traditionally with the market demand curve, but I'll fix it up later. But they're wedded to this vision, and they cannot escape it. But if they do escape it, we get a totally different form of economics, which would be a great improvement over what we have right now. So what I've been through is the empirical reasons why marginal productivity doesn't apply. The individual demand curve can't obey the laws of revealed preference, so the theory of individual consumption is wrong. You can't get a downwards market demand curve. Even with all that, there are still problems. If you say, let's ignore all that, assume you have got a downward sloping market demand curve, you assume you have got an upward sloping marginal cost curve, there's another problem, which I'll give you at the beginning of next week's lecture. So, okay. I normally do this in 3 hours, that's why I'm going at such high speed. Can you cope?
Yes.
Okay, I'll put the recording up, and I'm sorry about those animations.